Hello students, welcome to SOURAV classes geology. Okay, and today we are discussing about the JAM Geology 2017 paper. And in this video we are start the discussion from the question number 7. What they said in question number 7, they said the conservative plate boundary is represented by from which of these faults? Is this normal fault, transform fault, growth fault, reverse fault, or what? Okay, so let us discuss about this question. So as we are discussing about what is the conservative plate boundary, a conservative plate boundary sometimes also called as transform plate margin. Why? Because it occurs where plates slide past each other in opposite direction. That means if I draw a picture like it will be a continent, okay, and another will be another continent. Okay, now if there are there's the underlying areas. Okay, now if there are a movement occurs between two of these continent, one moved in this side, another moves in just opposite of other. Okay, so the focus will be occurred in this area. See, the focus will be occurred in this area, and I can mention it as focus here, and epicenter will be this of this plate movement, because conservative plate margins many times produce a severe earthquake. Okay, so that's a good, and those are the sign of plate movement. And after this there are waves are seismic waves are occurred in both sides. Okay, so as I say, it transform plate margin or transform conservative plate boundary occurs when plates slide fast to each other in opposite direction, or in the same direction but at different speed. So it will be also caused at same direction but in different speed. Okay, so friction is eventually overcome and the plates slip past in a sudden movement. The shock wave created produces an earthquake. Like a good example of this type of transform plate margin is the San Andreas fault. Okay, so we can easily now say the conservative plate boundary is represented by the transform fault. So right answer for the question number 7 is the C. Now the second question is question number 8. What they say, which one of the following prismatic crystals belongs to the hexagonal crystal system? First we go for the option A. Okay, because we can describe it as you know, a crystals with small additional faces, like as they said here is 1120. That's the structure. Okay, so the diagram will be like this. First thing, it must be a slender prismatic crystal. Okay, The structure will occur like this. Okay, the structure will be like this, and when we meet the adjoining the lines, it will be like this. And where slight lines occur in like A, B, C, D and E. Okay, so as you can see here in the diagram, the long axis of the crystals lie in the plane of the vein. Okay, lie in the plane of the vein, and some of them about upon one another and some are terminated. With them in the matrix are rhombus, I can write here, with them the matrix are rhombs of calcite and flattened octahedrons of white spherite. Okay, the or we can say the Willemite crystal allow distinct basal cleavage, but all faces are dull and give poor readings. Okay, especially there were numerous secondary carbonate. There are numerous secondary carbonate veins which transfers the ore body. Okay, so that's why we can answer this question. Only the option A of the prismatic crystal forms belong to the hexagonal crystal system. Okay, so that's all for this video, guys. Thank you for being with us. Hope this video will be helpful for your preparation.